Action. Hello, everyone. Thank you for attending today's webinar. My name is Aaron Heineman, the Inorganic Product Line Leader for PerkinElmer. During this presentation, I am going to discuss how the Avio Max series can maximize your workflow and minimize your downtime. So let's first introduce you to the Avio Max series ICP-OES. The Avio Max series comprises of the hybrid simultaneous ICP, the Avio 220 Max, and the fully simultaneous ICPs, the Avio 550 and 560 Max models. The Avio 550 and 560 models differ in that they have a built-in high throughput system unit already incorporated into the system. Highlights of the three different models of the Avio Max series are shown here. All have the common benefits of low argon consumption, smart software, plasma shear, and a small footprint. So when developing the Avio line of instruments, or any analytical instrument for that matter, we like to look at what challenges today's laboratories face. Here, we have written some of the major challenges noted by our customers, those being operational costs, software, turnaround time, and bench space. Ways of lowering operating costs, including making systems easier to use, reducing the maintenance, and subsequently incurring less downtime, or perhaps less reruns, all the while consuming less bench space. In addition to the laboratory challenges, the laboratory is also challenged analytically with the ability to address tedious matrices, achieve desired detection limits, mitigate interferences, and increase productivity. So, what things do we look at when we're going to maximize workflow? Typically, a simpler interface in general can help the user get the task accomplished. How the user interfaces with the system as a whole, which includes both the hardware and the software interfacing parts, is an important aspect. A smarter software, being more intelligent, intuitive, and requiring less intervention, helps amplify that simpler workflow provided by the interface. And lastly, instrument readiness and capability. Is it ready to take on what the laboratory needs to do? Is it capable of doing what we need to do? Or does it require additional intervention, like sample dilutions or additional preparations? We want our systems up and running more and ready to run samples when needed. So key considerations when minimizing downtime or maximizing uptime is improving the throughput of the system, minimizing the system's exposure to samples, considerations in the design and optimization of the ICP sample introduction, and of course, overall method optimization. In the next few slides, I'll introduce you to features designed in the Avio Max series that will help you do just that, minimize downtime and maximize your workflow. The Avio Max series provides complete productivity offerings to accommodate low to mid sample volume laboratories, as well as mid to high sample laboratories when you incorporate automation features. Performance of the system provides excellent detection limits, outstanding resolution, and increased sensitivity, especially for those UV wavelengths. Value is obtained by the reduction in argon usage, reduced maintenance, and providing a smaller footprint for the laboratory. By upgrading PerkinElmer's Avio with the High Throughput System, or HTS, we have further maximized the system workflows, creating a complete solution that provides enhanced productivity and performance. As shown here and demonstrated in a few of our application notes, the HTS delivers a higher throughput, which in essence maximizes both the workflow and uptime, more time to run samples, and less exposure to samples throughout the runs. For some additional insight into the practical use of the HTS with the Avio 560 Max, please use the Handouts section to download this application note, or visit perkinelmer.com/Avio Max. This particular application note covers EPA method 200.7, and notably, it is run with a sample-to-sample time of 60 seconds. 60 seconds from sample to sample, further demonstrating many of the features I have discussed earlier. First and foremost, as mentioned on the previous slide, minimizing downtime with an ICP-OES is directly related to the design of the sample introduction. The flat plate plasma, plasma shear technology, and vertical dual view ICP, when all combined, provide significant benefits to the user. The flat plate plasma produces a more robust plasma and greater stability, leading to greater analytical signal, lower argon consumption, no maintenance compared to copper coils. With the plasma shear technology, the cool tail of the plasma is cut off at the top, ensuring fewer interferences, better data, and it eliminates the need to clean cones or orifices that the plasma may impact, especially for high TDS samples. And it only is consuming compressed air instead of argon like other systems. The vertical dual view design provides the Avio with high matrix tolerance and more accurate results for challenging samples. Other system design considerations in the Avio 550-560 Max series are in the optics. The Avio boasts a free-form optic, the Schmidt cross disperser, which has a customized surface that is shaped to correct for light aberrations, to deliver outstanding resolution, and ensure excellent light throughput. In addition, the off-axis optics, designed with computer-controlled mirrors, reduces the stray light that reaches the detector, providing excellent detection limits. All optics in the system have a coating that is specifically designed to increase sensitivity, particularly in the UV range. And last but not least, the dual detector design. One detector for UV spectra and one for the visible spectra allows for the optimal collection of aberration-free light, ensuring optimal performance of the system. Why do you sell the Avio 220 Max? The answer is simply, this is an excellent performer with lower capital and operational costs that is always ready with its plug-and-play design. This hybrid simultaneous instrument simultaneously measures the wavelength of interest and the range around that analytical wavelength. All background correction readings are made at exactly the same time as the analyte measurements, and the design provides significant benefits in analytical accuracy. For many analytical methods, the Avio 220 speed is very comparable to a fully simultaneous system. The plug-and-play fast startup design of the Avio 220 Max allows the user to begin the analysis from a cold start, completely off, no power to the system, in 10 minutes. So it's ready within 10 minutes of that cold start, eliminating warm-up time practically, allowing for running the system without an argon purge when it's off, so there's no argon consumption and no electricity or chiller noise when not in use. It's completely shut off the entire system. The dynamic wavelength stabilization, or DWS, design provides exceptional wavelength stability over the course of the analysis and is what enables the system to provide that fast startup from the cold start. Another way the Avio 220 Max provides maximum capability is the attenuation mode. With the attenuation mode, desired wavelength can be attenuated by changing the aperture size, providing an order of magnitude more linear range to work with before detector saturation occurs, which increases uptime and minimizes downtime due to less reruns or manual dilution required. So, Syngistix for ICP software. It has been designed to optimize the performance of the Avio Max series and improve efficiencies of the lab. Syngistix for ICP software mirrors the progression of users' workflow, guiding users through each step for greater control and confidence. The latest version builds upon the smart methods and smart data aspects of the software by providing smart features like automatic background correction, enhanced data viewer upgrades, sample limit indications, replicate data, auto sampler information, and an enhanced calibration review with residual error results for each standard in the calibration. We also have an API or application programming interface that has been created to allow users and third parties to create remote control applications so we can move some of the control of the ICP into remote clients. All of these updates are also incorporated into our enhanced security version of the software, which provides an optimized workflow for laboratories requiring 21 CFR Part 11 compliance. Syngistix for ICP software provides a wide range of features to save time and effort during all parts of the workflow. So, smart workflow in the software starts with the scheduler. Scheduler lets the user automatically schedule instrument procedures, including auto startup, auto shutdown, and warm up. Our Express Analysis provides quick start capabilities in one window, so the user can turn on the plasma, select a desired workspace, and start the analysis just by a click of one button. Our Sample Information Editor allows the entry of all the sample information that the user will need for the particular method. And it'll allow for the automatic calculation of the results with potentially user-defined units as well. The status panel in the ICP provides real-time progress updates and quick links to other areas of the application for simple navigation. PlasmaCam, shown in the top right here, simplifies method development by offering continuous viewing of the plasma and enables remote diagnostic capabilities for maximum uptime. And as always in the software, if you need help, press the F1 key and it'll bring you right to the relevant section of the help file with specific information on what is currently active in the software. Smart software, smart workflow. Now, smart methods. In Syngistix for ICP software, we have method check as an example. It assists with the method creation by checking for any possible errors in the method. So if the user inadvertently entered something that shouldn't be in a particular field or doesn't make sense for that type of method, smart check, method check will let the user know. Universal data acquisition. All data, all the time, on the Avio 550, 560 systems. Allows for the user to go back and look at their data, look at various wavelengths, post-analysis. Various modes of analysis, like high, normal, and low resolution, is also possible on the Avio 550, 560. As mentioned earlier on the Avio 220, attenuation is available. With multi-component spectral fitting, we can significantly improve detection limits, accuracy, and precision. And that combined with automated simultaneous spectral and background correction makes it simple to get methods up and running quickly. Smart methods are further improved with automatic background correction. Automatic background correction uses a proprietary PerkinElmer algorithm that dynamically creates a background correction spectrum with no user interaction required. The algorithm takes the points in the sample spectrum itself and calculates the best fit of background spectrum. Automatic background correction is then subtracted from the original spectrum to get the background corrected results. So automatic background correction is the default setting for spectral corrections in all new methods that are created and fits sloped and complex spectra just as well as flat baseline spectra. Syngistix also provides a number of smart monitoring features like quality control, internal standard plotting, sample limits, and nebulizer back pressure checks. The software provides automated scheduling for quality control samples and automated actions during the analysis, all without manual intervention. Notifications of failures are possible by sound, email, and even text message. The tubing saver features help the user avoid the crushing or distorting of the pump tubing when the peristaltic pump is not turning, when it's not in use. While the fast pump and smart rinse features of the software dramatically improve the sample rinse out and analysis times. Some of the last features, but not least, are the smart data features of the software. The data viewer in Syngistix provides an environment to quickly and easily review calibration curves, RSDs of concentration and intensity, replicate data, mean data, and then it provides charts for internal standards and quality control samples. Charting of the internal standards and quality control samples allow for easy outlier identification or any failure identification during the analytical run. The Edit Calibration window provides the user the option of deselecting or recalibrating a particular standard within a calibration. And Automatic Export provides a template-based export to automatically send an exported result set at the end of the analysis. A guided workflow is also provided for creating these custom reports and exports so that the user can customize as needed. So in addition to all the wonderful and smart features mentioned, Syngistix Enhanced Security Software enables 21 CFR Part 11 compliance. With this version of the software, an administrator can set up users and group permissions, assign data folders, customize electronic signatures, and set up login notifications within just a few clicks. It has Active Directory integration for user authentication. The ES Tools data mode allows for side-by-side comparison of results, spectra, calibrations, as well as the ability to review and add signatures and comments to the data sets. Auditing tools are provided with an event log, login history, method versioning, review and approval information, and functionality that prevents a user from self-approving their data. Enhanced security tools provide sample and batch reports with all of the e-signature information for proper data integrity purposes. The method mode allows the user to view differences between methods, the method versions, It allows users to look at different CIFs, MSF files, IEC files. So overall, with Syngistix enhanced security software, data integrity is ensured with this secure interface and record structure. So, in summary, the Avio Max series has maximized workflow and minimized downtime. Maximizing workflow with simpler hardware and software interfaces, smarter software features, and instrument readiness and capabilities. Downtime is minimized by improving throughput with things like the HTS and other design characteristics of the Avio series that will minimize system exposure to samples. The sample introduction, design, and optimization also leads to less downtime. And of course, method optimization. So I would like to thank everyone for listening, and I will have time for questions. All right. Well, thank you very much for joining. Again, time for questions here. Feel free to submit additional questions in the question pane here. And another reminder, there are some handouts available for download in this webinar interface. So go to the handout section of GoToWebinar. Depending on which interface you're using, you can find the handouts there. The brochure, a few application notes are there, as well as a current promotion. All right, so just looking at the questions, had a question regarding, can this unit be used to analyze lubricant oils? Actually, very good question, because I didn't cover that in this presentation. I probably should have. We actually have another model I didn't talk about. It's kind of a sub-model of the 550 that was actually developed specifically for oils analysis. It essentially comes with lubricating oils analysis front end, so spray chamber, nebulizer, and associated accessories for lubricant analysis. So yeah, it definitely can, and it's widely used in the lubricant world. Oh, so I had a question. Yeah, this is always a interesting one. I get this question once in a while, from people. What is the difference between OES and AES in the world of ICP? And are these the same? So yeah, they're the actual acronyms stand for optical emission spectroscopy, or spectrometer in the case of the spectrometer, or atomic emission spectroscopy, or a spectrometer in the case of the spectrometer. And yes, they're the same technique. Different manufacturers or vendors over the years have used one or the other, typically. And, just kind of, my opinion, over the years, OES, the reason why optical emission spectroscopy is used versus atomic emission spectroscopy, those familiar with the technique know that it's not always just atomic emission we're looking at. We're also looking at ionic emission. So using optical emission spectroscopy it captures both the atomic and ionic forms of light emission we're looking at. But in essence, they're the same technique. So I'm just looking. There's a question more on the software. Is there a way to print everything that is run during the day, even if you have reset sequence? Now, I don't know about the particulars of what's happening or what you want to print, but there is. I mean, there's functionality in the software to print what we call a sample analysis log as it goes. You could, at the end of the run, generate a report that also encompasses all that with spectra, calibration data, all of that as well. I would reach out to your local, application scientist or representative and kind of guide you through more of the particulars of how reporting works. But yeah, there's a ton of functionality with regards to reporting. Even if you've reset the sequence, so if you've reset the sequence in that scenario, it may be best to generate the report post-run through our data manager utility. Question here. So what a question on what is the compatibility of consumables, so torch, injectors, etc., with previous instruments, specifically the Optima series. So as you can see, the Avio systems are a vertical dual viewing system. So the torch has been redesigned for that orientation. The torch, injector, and spray chamber, really how it mounts to that assembly, has been redesigned. So those are different. So those part numbers are different for the torch body, all of that. Injector is different, as well as the spray chambers. In any instrument, you can use nebulizers. Of course, nebulizers are transferable amongst the models. I had a follow-up question on oils. What is the name of the unit? It can be used for lube oils. It's actually simply called the Avio 550 Max oil. And it's just a slight part number change, and it just comes with all the nebulizer, spray chamber, torch, injector assembly designed for solvent or oils analysis. So I had a question. Does the Avio use both nitrogen and argon, and what gas is used for flushing or conditioning? We call it a purge gas, but yeah, the answer is yes, it can. It can use both nitrogen and argon. Nitrogen is typically the preferred gas of choice for purging an optical bench, such as the Avio, since it's cheaper. It's less expensive than argon, so therefore, you typically would use it for purging optics in general, typically over argon. Obviously, there's different use cases, but in the case of not wanting to run a gas line for each, you could potentially use argon, especially a lot of laboratories that have the Avio 200 or 220 systems, where they're completely shutting off the system between uses. They don't run it very often. Maybe they may run it once or a couple times a week and want to completely shut off the power and gas supply to the system, and maybe just run on some compressed cylinders of argon. And they don't want to plumb nitrogen in or have a nitrogen cylinder available. So a lot of those cases, you'll see those users use argon for both the purge and for the plasma. There's a question, a software-related question. Can I set up my system to run more than one method? Yes. The answer is yes. It can run a series of methods. It's in our analysis window interface. Essentially, there's two options in there to run. It has an option to run the active method, the method that's active, or to run a predefined series of methods and associated samples with those methods. So yeah, you can string together, I don't even know how, there's a lot. There's more than anyone could practically ever use. If you need more details on that, I really don't have, it set up here to demonstrate how to do that, how to string it together. So if you'd like to reach out to me after, I can either direct you to somebody that can, or I could potentially show you myself how that works exactly. And then another question. Can you compare ICP-MS versus ICP-OES? That's a whole big presentation on its own, in my opinion. So maybe I'll leave that to another presentation. So I had another question. This is a good one. Sounds like this user has an Optima 7000 dual viewing instrument with the cyclonic spray chamber. Which new instrument would be the direct replacement? So for the Optima 7000 DV, the direct replacement would be the Avio 220 Max, and they're all dual viewing now. So you don't need to distinguish between a non-dual viewing and dual viewing anymore with the Avio series. So that would be the direct replacement. Is there an automatic way to generate IEC and MSF models? So IECs and MSF, again, it's a whole. Actually, we did a webinar on IEC and MSF model generation just at the end of 2020. I can refer you to that. If you go to our website list of webinars, and more specifics on how to do that. But just the essence of generating IEC and MSF is there's a little bit of work. You got to put the solutions with those analytes in them to generate them. So there is some human intervention, of course, required there. So yeah, please refer to that webinar. It does really get into more of the details of how to create and how you can create IEC and MSF models. We had a question about a distributor or agents in the world. Yeah, I mean, we have distributors and agents all over the world. Please reach out to myself, and I can direct you to the appropriate person if depending on where you're located. Had a new question. I'm just reading through some of the questions here. How does the Avio 220 compare with the competition with price point? Competitive? No, the 220 is actually a little lower cost than the fully simultaneous instrument. There's a little bit less hardware in there, but also it's a much more robust instrument over time. As I said, you can completely shut that off and then turn it on, and it's ready to rock. If I had a lab where I'm just doing, running a few analytes or running infrequently, I would really pick the 220. Really, it's a nice, stable design instrument. When you get, detection technology like CID, CCD that needs cooled to -40 C or below, that requires more overall stability. All right. Well, I don't see really any more questions. So I want to, again, thank you for your time. Everyone that's registered will get a link to the eSeminar series, our webinar series for atomic spectroscopy. Also get a link to the recording of this webinar. If you go to this link that you get with the webinar series, you'll see a list of on-demand, and specifically the ones we've done in the past on some of these topics that came up in the questions here. So please check that page for more webinars. And so now I'd like to thank everybody for their time today, and thank you for attending this webinar. If you have any questions, feel free to reach out. All right, have a great day. Take care.